Good morning. My name is Paul Stack. This is my talk on infrastructure as software. I'm delighted to be speaking at stackconf this year. It's a shame I'm not actually there in person, but due to the current world events, we all understand what the situation is. I'm here today to talk about why we believe at Pulumi we are creating the next evolution of infrastructure as code tooling that will allow us to treat infrastructure as software. So each company can be at a different level or a different version of their cloud transition right now. We all know that cloud is a real thing and we all understand that people are using cloud in many different ways, but it's a situation where different companies can have different levels of adoption within the cloud. So let's think about V1, which is traditional N-tier style architecture. They've effectively picked their database servers and their web servers up from their physical data center and they've moved them to the cloud. Now, this is traditionally longer lived servers. They're managed by infrastructure as code tooling, maybe Puppet Chef, Ansible, SaltStack, all these different tools. And it's longer lived management of these systems. Then we get into V2 of the ecosystem, where it's a little bit more transitional. So you're starting to take advantage of maybe some containers, maybe some hosted services like hosted databases. You're starting to create a little bit more immutable servers that you can tear them down and recreate them on the fly a little bit more, and things become a little bit more immutable in how you manage your infrastructure. So you don't make changes to your infrastructure itself, you actually just deploy a complete version of a new server or a new application each time that you actually change something. And then we have like this V3 style architecture. Now V3 is there are many different names for it. People call it cloud native. There's people who are treating it as microservice based architecture. It's a very dependent naming of what you actually want to do with it yourself. But if you think of it as it's really, a mix of containers using probably an orchestration engine like Kubernetes or HashiCorp Nomad, you're probably taking advantage of some serverless. It's nearly all public cloud. You're taking advantage of a lot of hosted services that are already there, and that you can actually effectively run everything that you need to in a specific cloud. So you're taking advantage of real like Lambdas and your S3 buckets and your analytics solutions and machine learning, all these different things together. Now, we've been through the era of moving to infrastructure as code and proving what infrastructure as code is. And it's a way of being able to create these style of architectures, these V1 and V2 style architectures. But there's nothing really that sort of sits in this V3 era. And this is where we believe that Pulumi actually comes in. So Pulumi is an open source tool that allows you to declare your infrastructure using real languages. And we actually call it modern infrastructure as code because you would create your code using your real language. You would actually use your favorite tooling, your IDE, your testing tools. You have a CLI, which will allow you to integrate into your CI/CD pipeline. And of course, CLIs are how we all know about how things have been created, managed, and deployed. You get the full preview changes like you would in other tooling, and you get the full audit control changes like in other tooling. But the most important here is that it's actually real code. We don't say that it's infrastructure as code. It's actually real infrastructure as code, not just DSLs or YAMLs or JSON. So we actually believe that this is much more bringing us towards infrastructure as software. So for us, we can take advantage of all of the software development practices that people have been learning throughout all of their careers and all of the years of software management that has come before us. So semantic versioning, testing, coding reviews, PRs, all of these different things. And you can actually embed this in your infrastructure process. Now, Plumie can give you a number of layers. So let's look right at the bottom where we say we have the foundation. The foundation of Pulumi is providers. So we actually interact directly with the clouds. So AWS, Azure, Google Cloud, Kubernetes, New Relic, Datadog, Cloudflare, OpenStack, DigitalOcean, VMware, Packet, PagerDuty, Auth0. We have a lot of different providers that allow us a lot more flexibility in how we integrate systems together. But because it's real code, you can start to build libraries, cloud-specific libraries on top of those providers of your own layers of abstraction. either container-based, serverless-based, or infrastructure-based. And then Pulumi have actually taken this idea a little bit further itself, and they've created frameworks. So the framework that we have actually created is called Pulumi Crosswalk. And Pulumi Crosswalk allows us to give developers and operators a simplistic way of declaring infrastructure that would require a lot of boilerplate. So for example, in AWS, if you require a VPC, you would need the VPC components, you'd need the subnets, you'd need the route tables, the routes, the route table associations, the internet gateways, the NAT gateway, the elastic IPs, all of these different pieces. Now in Pulumi, that can actually be as simple as one line of code to deploy all of these resources, because Pulumi have been able to create a library and a framework that wraps all of this away. Now, we're code. Because we're code, we can actually integrate with your source control tools. You can write in real languages, JavaScript, TypeScript, Python, Go, C#, F#, VB. There's even some unofficial support for PowerShell. You can hook into your CI/CD pipeline. And of course, as I said before, just previously, you can hook into a number of different environments. AWS, GCP, Azure, and so on and so forth. Even though Pulumi is real code, it is actually declarative. What you declare in your Pulumi application is the end state of your resources. Now, it may sometimes be wrapped in a layer of abstraction, which makes life a little easier to do a lot of things, but it is actually declarative syntax. We can take advantage of conditions and loops. So in this example, we only provision our subnet if there is a variable that is declared for public subnet siders. We can take advantage of multi-provider workflows. So the inputs, or the outputs of some resources can be the inputs of other resources. So in this case, we're creating a bucket, and the bucket domain name is then part of our Kubernetes application deployment. We can reuse our code. So we can package our code up. We can create our own internal packages that we can distribute, and real packages, so like pipey packages, npm packages, NuGet packages, and we can share those internally or publicly, of course. And then we can start to do more interesting things. So this advanced orchestration example shows that we would want to deploy 3 replicas of a canary, an application canary. When we have deployed 3 versions of our application canary, we would then make a request to Prometheus in order to check our application metrics, that our application is working as expected. So we've integrated code that actually talks to the Prometheus API and the Prometheus SDK. When we're happy, we would then roll out the rest of our 10 replicas. So of course, in traditional tools, you would have to make a deployment, then you would have to go to your tooling, you would have to check that everything works as expected, and then you would have to go back to your infrastructure code, and you'd have to change the number and redeploy it. In this, it can embed it in one specific workflow. One of the things that we've added in Pulumi 2.0 is the ability to test drive our infrastructure. Now, this for us is something that's extremely interesting, because infrastructure testing has not really been very prominent throughout the years. And we know that it takes time for some resources to spin up. And that is a very slow development loop where you have to wait for resources, let's say EKS, which takes something in the region of 20, 25 minutes. You then have to verify that your code has deployed everything as expected, and then you would tear it down again. In Pulumi, we can actually really write unit tests, because we have allowed you the functionality to mock the responses and requests to the cloud. So we understand that if you send the cloud a well-formed request, then the cloud will actually handle that correctly. But usually we would be testing, and we would actually be testing if the cloud itself has spun out what we wanted. So in Pulumi, we're trying to take that away, and we're saying, maybe what you do is you test that the code and the infrastructure that you've written is fit for purpose, rather than actually testing that the cloud has spun up that infrastructure. So it's a very interesting workflow that it's allowed you to do. I have a number of talks out there right now on this specific workflow, and I can link some content during the talk. And my favorite feature of all of the Pulumi features, because I don't believe it's as good in any other tool out there, is the secret management. we are traditionally bad at secrets. I would love to say that we're not, but unfortunately, we're really bad at secret management throughout our industry. We have numerous examples of that happening. So at Pulumi, we've actually taken the idea of being able to manage secrets built in and do everything that we actually need to do. So we have a secret manager by default on every Pulumi project, which is called Pulumi KMS. So that is an AWS KMS key that has been assigned to your Pulumi org and your Pulumi project. But of course, you can bring your own. You do not need to give Pulumi your secrets to manage. You can manage them in AWS Key Vault. You can manage them at, AWS KMS, Azure Key Vault, GCP KMS, or if you have HashiCorp Vault already running, we will also integrate with that. So it's something that we actually tried to do in order to promote safety of secrets throughout your application lifecycle, rather than just what we would do now in the industry is think of it afterwards. So the makeup of how Pulumi works is we have a CLI. Our CLI is our client that sits on a local machine, or it sits on a CI/CD machine. It's your choice, and it reads the credentials from that machine. It makes two requests. It makes a request to your cloud with the provider API call, so it authenticates to the provider API. It will make the request, and it will actually spin up your infrastructure, and it will get the response back. And then Pulumi will store your state by default in the Pulumi SaaS. Now, it's very important to know here that Pulumi will not transport credentials to the Pulumi SaaS. The Pulumi SaaS has no idea what your credentials are. There is no connectivity from Pulumi SaaS to your cloud. They are completely independent of each other. And if you're not happy using Pulumi SaaS, you can swap it out and you can use an S3 bucket, an Azure Blob, a GCP bucket, Artifactory. You can use a lot of different features. You can use the command Pulumi login with a cloud URL, and you can pass in the URL in which you need to store your infrastructure. So let's write some code. Let's demo some pieces of infrastructure that we can actually test in order to bring some work together. So I'm going to create a new application. The new application, I can, by default, Pulumi is a CLI, and the new application will allow me to scaffold the application and bring all of the information that I require to a Pulumi new application. So if I run the command Pulumi, it will give me the basic outline of all of the pieces of infrastructure that it needs. Today, we're going to use the Pulumi new command, which will allow us to scaffold a Pulumi application. I'm going to choose AWS TypeScript, and it will ask me the project name. Stackconf is perfect. A description of the project, and then it will ask me to create a stack. So stacks in Pulumi are the ability to segment different versions of the same infrastructure. So what I mean by that is, if you think of stack as an environment, so you can have a dev stack, a test stack, a prod stack, or you can actually have a developer stack. So Paul's stack, you can have Kevin's stack, Steven's stack, Michelle's stack, and so on and so forth. So there's a lot of different pieces of information that you can actually store in a stack. And it will actually use the same base Pulumi application each time. So it's not going to do something completely different here. So we're just going to say dev today. And because it's an AWS project, we are going to deploy it into, I like US West 2 because it seems to be the most reliable region for me in the cloud. So it's just gone and installed an npm package. And now we can open up our ID, so we can actually have a look at what's going on in here. So in the IDE, we can see a number of pieces. So the first thing we can see is it has installed, I'm using TypeScript, so it has installed all of the Node.js modules that it requires. It has a git ignore file. It has index.th, which we'll come back to. It has the package files, which locks us to the specific versions. It has a Pulumi.yaml, which just talks about the runtime of the application and some project metadata. And then it has a pulumi.stack.yaml. I chose the dev stack, so it's pulumi.dev.yaml. And we can see that we configured this dev stack to run against US West 2. We can have another stack that runs against a different region with different credentials and to a different AWS account or so on and so forth. The most important thing for us is the index.ts file. So there are three pieces that it brings in by default. It will import all of the required packages that it needs. It will import the Pulumi helper packages. It will import the AWS package, and it will import the crosswalk package because we try and promote the crosswalk as a good way of doing things by default, and that's the AWS package. Then we can see we have a real resource declaration. So it is namespaced AWS.S3. So there is also AWS.EC2 or IAM or RDS or Lambda and so on and so forth. And then we have the resource inside. The resource, then we can step into what it's actually, the constructor of the resource. So we can see it takes three parameters. It takes a name. The name is the unique name of the resource that needs to happen within the Pulumi state. It has some arguments, which we will look at in a second. And then a little later, we'll look at this custom resource options. And this allows you to be really a little more flexible with your infrastructure so that you can actually do a little more unique and specific things with it. So we can see that my bucket is there. And then lastly, we actually export the name of the bucket. So if I env chain AWS, Pulumi, AWS CI, Pulumi up. Env chain is just a way of managing my credentials on my local machine. You do not have to run this yourself. Then Pulumi will give us a plan of what it is going to do. So it will understand that it needs to work its way down the Pulumi application, work the resources out and then the orders that it needs to create them, and it will tell us that it's going to create the stack and it's going to create a bucket. Now, we can have a look at the details of what it's actually going to do, and we can actually see that it's going to create a bucket called myBucket-prefix. So let's say no to that, and let's go and have a look at our resource declaration again here. So we actually see that bucket, we actually only gave a name to my bucket as my bucket. Pulumi will employ auto naming by default. There are a number of things in the cloud that you cannot use a create before destroy mechanism if you use strong names or hard names. So Pulumi actually will auto name with a suffix on the end of your resources so that you can actually create a new one before you destroy the old one. You can override that if you really want, there's no problem. So we can actually say bucket, and we can say stackconf demo. And if I go back to Pulumi, and I say Pulumi up, then now it will actually tell me that it's going to create a bucket of the exact name that I wanted it to create. And it'll be a second. Let's have a look at the details. We can see stackconf demo. We will say yes to roll this bucket out. Now, this bucket is now under state management. State is an interesting concept. I believe you need state. You need to understand the state of your infrastructure because you don't deploy your infrastructure in a way where you only have the number of resources for your application. We reshare accounts, we reshare a lot of different things. So it would be dangerous if we didn't understand what resources in our cloud are actually being managed. And we can have a look at any time about the state by running the command Pulumi stack export. And we can see, let's firstly go and say, hey, look, no secrets, no AWS credentials are actually being transferred or stored here. This is the exact JSON blob that is being sent to the Pulumi SaaS. I'm logged into the Pulumi SaaS because I can see right here. And we can see that it has a stack, which has the outputs that I've specified. It has the outputs that I've specified. It has a provider because we can load many different providers in our application. Then it has the bucket with all of the imports and outputs that it actually, what it needs for the different pieces. So let's go and do something a little more to show the flow here, show that state is actually a thing. Let's add some tags. So we can get tags. And of course you can see my IDE is telling me straight away, if there's a problem, there's no such property as task, it's not there. but tags actually allows me to give. So you know, it's telling me everything that I need to know. So let's say owner stack 72, and let's say Pulumi up again, and it'll show me that the only thing that it actually needs to do at this point is manage the tags. So we can say details, and we can say the tags. So let's say no, and then lastly, we can Pulumi destroy, because it's only going to destroy the specific stack and nothing else. Details, just the bucket, just the stack, and I can promise you there are hundreds of AWS S3 buckets in this specific account. So let's destroy it and let's go. So let's go and do something a little more interesting here. So I am going to create and get some predefined code that I already created, and I'm going to bring this into my application. So first thing, I am going to get an AMI, and our AMI will be an Ubuntu 18.04 AMI. Then I'm going to declare a key pair. Please don't do this way of declaring your key pairs. This is purely for demo purposes. And we're going to declare a security group. And again, this is just for demo purposes. Please don't do inbound and outbound to everything. That's a very bad idea, and I'm not showing that that's what we should do. So then we can say let web servers equals an empty unbounded array. And I can say for let x equals 0, x is less than 100, x plus plus, and I'm in a basic programming loop right now. Then I can say const web server, actually just server equals new AWS dot EC2 dot instance, and I can call it my demo instance, and we need to give everything a unique identifier, so let's give it x, and then we can actually go into the arguments. We need to give it an AMI. Our AMI from above we can see is Ubuntu, so we can say Ubuntu dot ID. We need to give it an SSH key, a key name, I apologize, and it'll be SSH key dot key name. We need to give it some VPC security group IDs, and I want to give it open security group.id. And lastly, we can give it an instance type. Now, remembering these magic strings is painful, but as you can see, Pulumi is auto-suggesting all of these magic strings for us, or we can actually go to aws.ec2.instancetypes and get all of the constants that go with that. Let's just choose T3 smalls today because that's nothing else. And then lastly, we need to push the server onto the array. Now, as you can see, straight away, we have an error, and we can actually say, see that string is not assignable to an array of string. So we know that we actually have to surround that because it's an array, and we have everything there. And then lastly, we want to export const IPs equals web servers dot map x dot public IP. So we actually have a real working application right now, which if we run Pulumi up just to get the preview, we will see that it's going to create the security group, the key, the stack, and 100 resources. We'll just let that plan for a second. And we can see everything's there. So we're going to say no to that. So why don't we take this a little further? Why don't we create a file called webserver.ts? And the first thing we need to do is import star as AWS from at Pulumi AWS, excuse me. And then now we can actually export class web server. Our web server will have a public read-only VM, which is of type aws.ec2.instance. And then we can have a constructor. So our constructor will have a name, which will have a string. It'll have an AMI ID, which will be a Pulumi.input, which we'll talk about in a second. A string. And lastly, it will have an instance type, which will be an aws.ec2.instance type. So we have all of the different pieces. I need to import Pulumi. I apologize. Star as Pulumi from Pulumi. Now, as an operations person, it would be nice to be able to abstract a lot of the different components that we allow our developers to handle away. So what we can actually do is we can take that specific component away from them. So in this case, it would be the SSH key, which would be centrally managed maybe, and the security groups, because we really don't want developers creating security groups this open. And what we can actually say is that this .vm, so the instance of the VM that it returns is a new aws.ec2.instance type .instance, and it'll be, let me just make sure that the names are the same. Actually, we can just pass in the name, it's fine. So the name here in this case will be just name. The parameters that we can actually create it against will be, so our AMI will be our AMI ID. We will use an instance type, which will be an instance type. We will use a key name, which will be sshkey.keyname. And then lastly, we will pass in a security group, a VPC security group IDs, which we know was an array before, as open sg.id. Now, everything I'm showing you in here is, of course, JavaScript, but you can very much do this in Python in exactly the same way. You can define your own Python class. In any language that Pulumi supports, you can do this and make it happen this way. So instead of creating a new AWS EC2 instance here, what I'm going to do, I'm just going to copy this string to make sure it's the same. And it would actually be a new web server. And you can see immediately my ID has imported the correct class. And we will have a name. Actually, we could just say name equals that. We can say it's ubuntu.id. And then lastly, we can say aws.ec2.instance types.t3 small. Now we can immediately see our IDE has told us that there's no public IP on X because X is a web server, but X returns a VM, and then we can get the public IP. So it's very easy to be able to refactor our code using Pulumi because of the fact that we are using a real programming language and we can take advantage of the real constructs that go with it. So let's go a little further. I don't have a long time here. Let us go and have a look at the management of IAM. IAM is one of these pieces of information that is always a real pain because it's JSON, and we don't like to deal with JSON inside our declarative languages or pieces like that. So Pulumi has created helpers that allow us to do this. So let's say const role equals new aws.iam.role. Now, in person, I would usually give a prize. If anyone could tell me what the assume role policy for an AWS IAM role is. And it's usually like statement, version, all these different pieces, but I've created a lot of roles and every time I need to look it up. So Pulumi has created an assume role policy for a principal function. And the function will take a service. And the service in this case will be ec2.amazonaws.com. Now, if I go and run that, that looks extremely alien-like because there's no role with JSON embedded. But if I go back to Pulumi up and I have a look at what Pulumi has actually created here, then we will actually be able to understand that it has created the correct JSON structure for us. We can see it: statement, action, assume role, effect, principal, the SID, and the version. So Pulumi understands under the hood that that's actually the case. And we can try and deploy this just to make sure that it's a valid role policy. So I'm assuming that we will get it created right here. And it will tell us, there we go. And it is, AWS has accepted that JSON blob for the assume role policy. So we can even go a little further. So I have a list of policies right here. And I would like to attach each of those policies to the role. So I can say, so let counter equals 0. I can say for const policy in managed policy ARNs. I'm in my loop right now. I can say const RPA role policy attachment equals new aws.iam.role policy attachment. Now here we need to give it a unique name again. So let's do $counter plus plus so that we increment it. So it'll be 0, 1, 2, 3, etc., etc. And then we can actually attach the different pieces. So the policy ARN that we want to attach will be the policy from our loop, and we need to pass it a role. Now, usually here I would have to look at documentation that says, is it the role ARN that you have to pass in, or is it the role name, or different pieces? In Pulumi, it's a strongly typed, uses TypeScript here, which is strongly typed. I can actually pass the entire role object, and Pulumi under the hood will understand the correct parameter that it needs to pick up. And then I hate these magic strings as well. What happens if I need to find the magic string which allows administrator access so that I can run my local development machine? Okay, so I can say aws.iam.managed policies.administrator access. And if I go and have a look at what Pulumi is going to do right now, it will tell me it's going to attach 4, it will create 4 policy attachments, and we can have a look at the details. And if just look at the administrator role, which is the important one, role, oh, it's just going to tell me what it's actually going to attach. So if I say yes, amazing. Maximum field size of 20. Absolutely incredible. So I've attached the wrong roles here, so that's an error in what I'm actually trying to do. But it's very easy to be able to attach these different things in the way that we actually need to do it. So let's destroy that live demo bugs, and let's take it out of interactive CLI mode and say yes, and we can actually go and do something a little more interesting at this point. So I have 10 minutes, and I want to talk to you about secret management in Pulumi. So I'm going to npm install a package that will help me demo this. So if I say @pulumi/random, then this is a random package that will allow me to create random data so that I can show how things can be made into secrets. So how most tools do it right now is random from @pulumi/random. So most tools would require that you have an extra tool that wraps the tool that you're using in order for your secret management. But I told you Pulumi doesn't need that to happen. And in most situations, we would say this. So random password equals new random password. I'm going to say demo1. And in the interest of trying to appeal to an ops audience, the length of the password will be 30, and it'll have special characters just to make sure that it's a real password that goes with it. And then we can export that const of random password value equals random password dot result. Now I know that this resource stores the password in the results field, so that's why I'm outputting it so you can actually see what it's going to do on the application. Now if I Pulumi up this, we will actually see that it's going to create the correct password for us, but unfortunately it will store the password in the state. Not just because I have added the output right here, but just because of the fact that Pulumi doesn't understand that this is a password and that you need to treat it as such. We can see the result is actually stored in here. So let's create a new version of this, and let's call it random password 2, and it'll be demo2. And then lastly, random password 2 value 2. So I'm creating a new password. So I told you right at the top that Pulumi takes the Pulumi resources take a name, they take arguments, and they also take custom resource options. So inside the custom resource options, we have this idea where it's called additional secret outputs. And additional secret outputs is all of the names of the outputs of this specific resource that need to be treated as secrets. So we can pass as many names in here as we want. So what I can actually say is that result. I want to treat result of random password 2 as a secret before it is actually pushed out to the endpoint and into the state file. And if I Pulumi up, I'm going to say yes and skip preview to move it off interactive CLI. So I don't care about seeing that right at this point. And we will see that we get a new secret password. And it's not just secret here, it is Pulumi stack export. It is secret by default in our state file as well, because it is using Pulumi KMS to create a ciphertext that even if you leak this state file, it's going to be difficult for people to actually decrypt. Now, I told you we can push as many things in here as we want. Maybe we don't want our attackers to understand that it has a length of 30 and it has special characters enabled. So I can go back to Pulumi up, skip in my preview. We're going to see that no changes to our resources is happening right now. We're just instructing the Pulumi engine to encrypt those secrets. And if I go back to stack export, we will see that it has the result, it has special, and it has length, all as encrypted values. And then even in the provider itself, we can see all of the encryption that it's happening and coming out the back of it. So we try and be secret by default because it's something that's really important to us, and it's something that we really want to encourage people to do. But that's, of course, not the only way that people have to set configuration values to their system. If you need to pass a value in to the Pulumi configuration that will allow you to use it in a Pulumi application, then what you would normally do is Pulumi config set, and we'll say my secret password, and we can say password 12344 exclamation point. Now, if I go back to my Pulumi application and I look at my dev stack, because this is against the dev stack, we will see again, Pulumi doesn't understand that this is a password. So we can encrypt it passing -- secret. And we go back to our state file, our config file, and we can see that it has been encrypted using the same keys that I used before, because it is a key that is designated to this project and this organization in the Plumie SaaS. Just to prove that that is actually secret the whole way through, we can read this back. So let's import star as Pulumi from @Pulumi /Pulumi. And I'm going to say const config equals new Pulumi.config. So I want access to the Pulumi config block, and then I want to read my secret password equals config.getSecret. Secret that I've actually told it to create is called my secret password. So we would pass that into our secret for the name as the secret itself. And then I can just, to prove, export const x equals my secret password, because I believe that because get secret, it actually treats it as secret throughout the whole application, and there is actually nothing on. It's a type that has no parameters on the actual type itself. And I go back to Plumie up, skip the preview, and let's actually see all of the different pieces that it's done here. It's going to tell us it's going to create the new resource. It's going to the new output, excuse me. You can see the new output is of type secret. And lastly, if I Pulumi stack export, we can see as the outputs of the provider, we can see X is actually stored as a secret. So of course, this is really good if you have like passwords for databases or users that you're creating, and you actually need to, if you're creating an AWS user access logon, then it'll actually encrypt the output that comes back, and the user then would actually have to decrypt it using their Pulumi KMS key. Now, of course, we give you the ability that you can change your encryption provider. So if I Pulumi stack init help, it tells you we support AWS KMS, Azure Key Vault, GCP KMS, and HashiCorp Vault. And of course, when you create a new stack, you can actually tell it that you want. Otherwise, you can actually use a passphrase and you can restrict it to different people. So it's something that we actually try and take extremely seriously at Pulumi, because We really believe that secret management is a big thing and that we need to promote it better in our organizations. So that's Plumie in a nutshell. We believe it's the easiest way to program the cloud, and I really mean the word program correctly. I don't mean just make CLI commands using JSON or YAML or DSL. This is actually real applications that will grow as your real software would grow, because without infrastructure code, your software code doesn't go anywhere. It's never fit for purpose. It never makes its way to your deployment mechanism anyway. So it's just as important code as anything else. Thank you for your time. If you want to speak anything about this talk, you can tweet me, Stack72. I'm always on Twitter, or you can try and get me on email. I'm not so good at email, and it's paul@pulumi.com. And I hope you enjoy the rest of your conference. Thanks.